Hi, my name is Kregg Egan. I'm a manufacturing applications engineer here at GoEngineer, and today I'm going to cover extract machinable features, how to use it, why to use it, what the options are, and how to fine-tune it. So let's get started. Okay, to start, I've got a fairly basic part. The features are about as easy as they get. Something like this is a great part to start on if you are not familiar with extract machinable features. Now, I am using CAMWorks, but this is also applicable to SOLIDWORKS CAM users. And the first thing we want to do is we want to make sure we set up our stock and our coordinate system. This is before we even begin using the extract machinable features. Now, before I run the extract machinable features, I want to look at what my settings are. To do this, I'm going to go to Tools, CAMWorks, or SOLIDWORKS CAM, depending on what you're using, then Options. Now I want to go to my Mill Features tab, and I've got the Extract Machinable Features area. Now for CAMWorks users, under Method you have Manufacturing View and AFR. For SOLIDWORKS CAM users, it's already set to Manufacturing View, and you don't get the option for AFR, but that's not a problem. We want to be using Manufacturing View. It's the latest engine for running Extract Machinable features. So the feature types, these are all the feature types here. Now, if we were to deselect holes, it is going to find all of these holes as pocket features instead of a hole feature. Now, if we were to deselect non-holes, it's only going to find the holes, which is fine if all the other features are previously machined and we just need to do the holes. Now, face and part perimeter, I don't have those selected because it's going to generate a feature for every setup. That means I would have a face and part perimeter feature on each setup, which isn't ideal for this part. And we'll cover this a little bit later. Also, we have tapered and filleted and multi-surface pockets. Now, we'll go over these a little bit later as well, as they don't really pertain to this part. Now let's talk about our hole recognition options, our maximum diameter. What this is saying is, what is the maximum hole size that you want extract machinable features to find as a hole feature? So I've got it set to 3/4 of an inch, and that means that any hole larger than 3/4 of an inch is going to be seen as a pocket, so that I can use an end mill rather than a drill. Now, minimum included angle is saying, what is the minimum angle that a hole has to be for it to be found as a hole versus a slot, a corner slot. So anything that is 270 degrees or greater will be found as a hole. Now, we'll go over condensed split holes a little later. Create feature groups is going to group all similar features together. That's going to make it a lot easier for us to manipulate and keep a smaller feature tree and operation tree as well. We have check accessibility for through features. We'll go over that a little bit later, as well as simplify features and recognize features by depth. So now that I have the features that I want selected, I'm going to go ahead and run extract machinable features. What this is going to do is look at the entire part and try and find any feature that it can. Now that we've done that, you'll notice that our first mill part setup, or our first direction of machining, is on this face, because that's how I set up my coordinate system. And from here on out, the setups are generated in whichever order the extract machinable features put that in, but that's not an issue. We can drag or drag above or below mill part setups in the order that we want it to be. But you can see it's found setups on each face. So right off the bat, I've got a default strategy is rough rest finish, which is fine, but for this demonstration I want to just use a rough finish. That's going to give me less operations and quicker simulation. So I'm going to go to default strategies, and this number here indicates that we have 10 rectangular pockets with a rough rest finish strategy. I'm going to go ahead and just change that to rough finish, as well as our irregular wrapped pocket. And looks like that's all I need to change for now. And what I could do is, if I want rough finish to be the default strategy every time that it finds an irregular wrapped pocket or rectangular pocket, I can click Save to Tech Database so that it takes effect for all future parts. If I just want it for this part specifically, which is what I want, I'm going to click Apply, and you'll notice when I do, these strategies will go to rough finish. Okay, now I'm just going to generate operation plan. This goes through the tech database and matches the feature conditions and gives us our operations. Now I'm just going to select Generate Toolpath. So I have default settings right out of the box, CAMWorks, and I'm just going to head and simulate this for you. So these are all default settings. I don't have my tech database customized, and it really does a fantastic job just right out of the box. But we can fine tune it. We can fine tune our strategies. We can choose whatever tool we want, depths of cut, feeds and speeds, just about anything we want we can edit so that it keeps that for a future. So this did a fantastic job. In under a minute, it's done all the work for us. We may have left to change tools to a different diameter if we want, but the majority of the work is already done for us. So that's really where SOLIDWORKS CAM and CAMWorks earns its keep. It does a lot of that upfront work for us, leaving us with just a few minor edits so that we can really fine tune it. So let's switch to another part. I've got a part here that has a tapered pocket as well as a pocket with a tapered island, and then it's got a few basic features as well. So let's open up our CAMWorks options. Typically I click on this double arrow here and select CAMWorks options, but again you can find it under Tools, CAMWorks, or SOLIDWORKS CAM, Options. Now I want to be sure that I have tapered and filleted selected, as well as multi-surface pockets. Now on this particular part, because I don't have features on any other side, I might want to add face and part perimeter, because that's just going to generate for this one direction. So this may be one that I want to add those to. Now I can choose from the part perimeter if I want an open pocket type or a boss type. Now for this part, my max hole diameter is 2 inches and minimum included angle is 180 degrees, which still isn't relevant to this part because all my holes are 360 degrees. And I do have all of these selected, but we will go into depth more on these features in the next part. So now that we have these selected, let's go ahead and run it through Extract Machinable Features. Note that I already have the stock taken care of as well as my coordinate system. And because I only have features on one side, it's only going to generate one mill part setup. And take note that my holes do go through the part. So that's important when we have our options. We do check accessibility for through features. With that deselected, this may have actually created two setups and created one setup just for these sets of holes. So that's why we want to make sure that's selected in the majority of cases. So this has given us a face feature, perimeter, boss, and it's found our tapered pocket as well as our rectangular pocket, and it's found the island. So let's generate the operation plan as well as the toolpath, and let's simulate this and see what it looks like. So that's our perimeter feature. I'll speed this up just a little bit. Okay. So as you can see, it's left a little bit of material around the island as well as the tapered walls, which is actually a good thing because most people would want to use a ball and mill to get a nice clean finish on both of these tapered surfaces. So that's right out of the box settings. So if you can imagine, if I had spent a little bit of time fine-tuning my strategies, my tool selection, my allowances, this would be almost a completed part right after generating the toolpath. Let's look at the last part. This has multiple different features, some that could be maybe a couple different feature types. Now, I'm going to open up my options again, and for here I have face and part perimeter deselected. I do have condensed holes selected, and I'm going to go ahead and keep all of these selected. Okay. And let's talk about condensed split holes for a second. Here's the example of what that's referencing. It's referencing when you have technically one hole feature, but it's split between a cut extrusion. If we don't have the condensed split holes checked, it's going to see these as two different hole features rather than one. So it's probably wise to keep that selected so that it doesn't try and create two holes for the same hole. Okay, let's go ahead and run this through Extract Machinable Features, and let's see what it gives us. I like to just hover over these features and just see all what the features it collected. Okay, and so here would be an example of check for through features. If I didn't have that selected, it may have wanted to put them on this backside on mill part setup 3, because technically they could be cut from this side as well. And let's just generate the operation plan, and let's generate toolpath, and of course let's simulate and see what it gives us right out of the box. Okay. So overall, this part's just about complete. There might be a few minor tweaks we have to do, but again, the majority of the work is done for us. Now, there's a few other things I want to show you that are definitely going to make things a lot easier for you. I'm going to get rid of the other mill parts setups. And keep in mind that anything that we delete and leave in the recycle bin will not be generated again if we were to run extract machinable features. That can be good and bad depending on how you look at it. If you didn't want, let's say, this whole group to be generated again, you could delete the whole group and leave it in the recycle bin and it won't be generated again. But on the same hand, if you deleted it but didn't empty it from the recycle bin and wanted it to regenerate, it's not going to. So just keep that in mind. What I'm doing here is just leaving the mill part setup in this direction, because even though I have features on different sides of the part, I may only want to have extract machinable features, find features in just this one direction. What I'll do is I'm leaving my mill part setup 1, but if I didn't already have that there, what I can do is I can create a mill part setup in the direction that I want the features to be found. So even though I have features on different sides, if I create just one mill part setup, I'll right click and select recognize features. All that's doing is running extract machinable features in one direction. It's going to ignore the other sides of this part. So as you can see, we just got the one mill part setup. Our second option is going to be recognize local features. And I'm going to go open my options again. And if we look here under local features, we have smart pick and adjacent faces. I prefer adjacent faces, and what this is referring to is local features is an even more refined way of using extract machinable features. Not only are you using the direction setup that you want, but you can also select just a face of the features that you want found. So if I just want this slot, the holes, and the pocket found, I can select just this face, right click on my mill parts setup, and recognize local features. Now it says it found 6 features. It found all of my holes, as well as the circular pocket and the rectangular slot. So that's great. Now, in my options, if I just leave it to Smart Pick instead of adjacent features, it's more of a simplified version where it's only going to find the features on that face. So if I select this face, recognize local features, it's only going to find the rectangular slot and ignore all the other features that are adjacent to it. Okay? So let's look at a few other features that we haven't covered yet, which is simplify features and recognize features by depth. So to show you simplify features, I'm going to recognize features, let it find all the features that are on this direction, and let's pinpoint this irregular pocket. As we can see, the toolpath is showing that it's going into these holes and around. Now, if I don't have simplify features on, it's going to use this highlighted profile. It's not going to go into the holes, it's just going to stay on the outside. So simplified features really tries to give us rounded geometry. It can overlap some features that are at least a lower depth. So the floor must be lower than the floor that it's actually looking at. Okay, so now let's take a look at recognize features by depth. Because I already have that selected, going to show you what that's meaning. If I look here, it's found that this floor can be machined all the way up to the stock in one feature. We don't need two different features to do this. In some cases, you may not want Recognize Features by Depth selected, and this is going to take a little bit of trial and error on your part to just see what works best and understand how it works. But let's go ahead and run Extract Machinable Features again to give you an idea of the difference. Okay, it's now going to generate a rectangular slot at this height and another irregular slot at this bottom depth. So really, with it recognizing features by depth, it gave us just this one depth. It's not going to be cutting a lot of extra air, which this one would be. This would be cutting a lot of air where there's no stock, as you can see where my stock's set up. So you can see clearly that this wouldn't be the ideal option for us. Okay, well that covers all the options. I hope you enjoyed this video. Again, my name is Kregg Egan, and thanks for watching.